All right, what's up, guys? So today we'll be going over the Daisy Change USACO 2020 December contest problem number 2, which is Daisy Change. Over here, I've already done it, and I just want to go over my solution. All right, so the question is, every day as part of her walk around the farm, Bessie the cow visits her favorite pasture, which has N flowers, all colorful daisies labeled 1 to N, lined up in a row. Flower I has PI petals. As a budding photographer, Bessie decides to take several photos of these flowers, in particular for every pair of flowers I to J, satisfying the condition that I is greater than 1 and J is greater than equal to I, and N is greater than equal to J. Bessie takes a photo of all flowers from flower I to flower J, including I and J. And then she later looks at the photos and notices that some of these photos have an average flower, which means the flower that has P petals, where P is the exact average number of petals among all the flowers in the photo. How many of Bessie's photos have an average flower? And then the input format is the first line contains N, the second line contains those N flowers with the petals, and then the output contains a number of flowers which have the same amount of petals as the exact average. So let's just think about this question. So here we have one, two, three, right? So these are the 4 flowers with petals, right? And then over here it says that J is greater than equal to I, right? So J and I can be the same, so what does that mean? She takes a particular picture of every pair of flowers, right? Every pair of flowers satisfying this condition. Well, so first case, all of these individual values will satisfy the condition, correct? 1, 1, 2, and 3. Am I right? Because over here, it says an average flower is just P petals divided by the average number of petals. But in this case, she's only taken a picture of one flower. It never says she can't take one flower. She can't take a picture of one flower. Although it sounds kind of weird thinking that you're only taking a picture of one flower and then calculating the average, because it will always be that. That's exactly what's happening here. Every pair of flowers, right? So first off, you get 4 conditions just from these individuals, right? So you take these flowers, and then these are 4 conditions. And then after that, now you have to actually go through and see what the 7 other conditions are. So the first step in solving this question is realizing that there will always be n number of patterns anyway. So let's say I was given like 10 values for input, right? Let's say it was given 10 flowers, and then there were 10 number of petals, right? Even without doing any other calculation, you know that there would be a minimum of 10 patterns, because you could just take an individual picture and take its photo and then divide it by the average, which would just give you the number again. Okay, and now to find the other ones, what you'll do is you'll try to find every iteration in which J would be greater than or equal to I, all right? And for every pair of flowers, right? And we know that every pair of flowers satisfying, all right, yeah. So in this case, it would be you start with 1, right? And then you add 1, which is the second one, and you get 1 plus 1 over 2, which is also equal to 1. Now, does this satisfy the condition? Where P is exact number of flowers. Some of these photos have an average flower, a flower that has P petals, right? In this case, the average is 1, and there is a flower in here which is average, which is number is 1. So that means our count now becomes 5, correct? Okay, now we'll keep iterating through, right? Now we take 1 plus 1 plus 2 over 3. Well, that's a decimal, so it's not equal to any of these values. Now we'll take 1 plus 1 plus 2 plus 3. That is also a decimal, so that doesn't give us value. So now we're done with all the patterns for this one. Now we're gonna move over here. So 1 plus 2 plus 3 over 3. Does that give me something? Yeah, 1 plus 2 plus 3 over 3 gives me 6 over 3, which is equal to 2. Is there a value between 1 plus 2 plus 3 in which there is 2? Yeah, so 2 is similar, right? So our count now becomes 6, right? Now we take 1. Oh, sorry. Before 1 plus 2 plus 3, we have to take 1 plus 2 over 2. 3 over 2 is a decimal, so that doesn't count. 1 plus 2 plus 3 over 3, that works. And then finally, we take 2 plus 3 over 2. 2 plus 3 over 2 is 5 over 2, which is also a decimal. So what we end up with is 6. So 6 is the total number of flowers. And look at that. That's also the value here. And if you read it, it says every picture containing just a single flower contributes to the count, just like we talked about. So there's going to be 4 always added. And then from the ranges 1 to 2 and 2 to 4. Basically, in this case, 1 to 2, we're starting from 1, right? So 1 to 2 would be 1 plus 1 over 2. And 2 to 4 would be from here all the way to 4. So 1 plus 2 plus 3 over n. Over 3, I mean, sorry. So in this case, j would be 2 and I would be 1. All right, so that's basically how it works. Now we're gonna try coding it. All right. So here, I'm just gonna code on the USACO ID. So here's some import statements. We don't need throws I as exception because it's not really using file. It's not using file anymore. You can just use scanner. So the first step we're gonna do is just create our scanner to take input, and then I'll just take this input, and I'll just put it. Oh, not here, in here. All right. So we take the input, normal scanner stuff, and let's just say n is equal to the value which comes out. So in this case, n would give us 4, right? In count will be 0. We'll initially set it to 0, and it will increment each time. Each time we hit one of these cases where either it's just an individual value where the count will increase 1 time, a total of 4 times, or the count will also increase when you take the average and there's a value between that range which is equal to the average. But it starts off at 0. And then you could use an array list or an array. Generally, I tend to use array lists for bronze questions because first off, arrays are a little bit faster, but you get, if you're doing it right, like you should not exceed the 4,000 millisecond time limit, right? So you could use an array list or array, but array lists just have like less room for any index out of bounds and everything. All right, so right now, what do we want our array list to contain? We want our array list to contain all of these values, right? We want the array list to contain the values 1, 1, 2, 3, or it'll just should contain the n number of petals, right? Because then we want to like do some average and all those calculations on it. We should be able to store it for further reference. So this is just standardized, just adding stuff to the array list. Just temp.add sc.extend. That should, so now temp would, let's see. Like, so yeah, let me just pull out a doc. So in this case, temp would contain 1, 1, 2, and 3. All right, and then n would equal to 4 in this case. And then now what do you want to do is, so first step, we know that the minimum for any value, right? If you have 100 and none of them have a common average, we still know that there's going to be 100 possible values because of, you could calculate for each individual, right? Because for each individual, the average would equal to just that value. So what we're just going to do is we're going to iterate through this loop, right? And then how many times we iterate, which would be 0, because it starts from 0, is going to be n number of times. We'll just increase our count each time. So now what happens is our count would have, it had 0, but now it's gonna have 4, right? Because it's gonna iterate and increase itself. And now we're gonna have to try to find a pattern here. So what did the pattern here? I kind of talked about it here. The pattern would be, so we have this, right? 1, 1, 2, 3. We've added all the individual ones. Now the pattern is, you just have to take the initial value, right? And then you have to check for 1, 1, you have to check for 1, 1, 2, check for 1, 1, 2, 3. And then when you're done with all of those, you go to the second one and you start from there. So you can kind of see that you're gonna have to use 2 for loops, right? For iteration. One's gonna be the outer bound, and then one's gonna be inside, right? Inside for increasing by 1, like standardized to double for loops. And then there's, so yeah, it's a double for loop. So we're gonna start with 0, correct? Temp dot size I plus plus. This is just temp dot size would be equal to 4, right? So it's the same as n. I could put in n or temp dot size, they're both the same. And then Then we have for int j is equal to I plus 1. You want to start from plus 1 because you don't want to start from that position again. You don't want to start from I again because we've already taken that into consideration in this for loop. And then j plus plus. Oh, a little bit like that. And then basically what this for double for loop is that for it means that I'll start from 1, right? So let's say in this case our I would be equal to 1, and then our j would also be equal to 1 because 1 plus 1 is 1. And basically what happens is it will go from 1 to 1, and then it will increase the j value to 2. So then it will go 2, 3, 4. And then after it goes to 4, then I will become equal. I will then go to the second one, right? And then j will be 2 and 3. And then after all those values are done, I is going to become 2 and j is going to become 3. So our basic structure is there, but now we have to check for what do you call it? We have to check each range, right? Like we have to check 1 to 1, we have to check 1, 1 plus 2, 1, 1 plus 3. So for that, what we have to do is we have to have another for loop inside, which would be k. We'll say k. And k starts in the ith position and it goes all the way to the jth position, right? And why this will work is because now let's say I is equal to 0 right now, right? And j is equal to 1. So k is gonna go from 0 to 1, which would be from this position to that. And then inside of that for loop, I'll take the addition of these two and I'll divide it by 2, right? And then it will exit this for loop, and then j will become I plus 1, which will become now it was I plus 1, it was 2, it was 1 before, and now incremented, so j will become 2. So again, I'll go in the for loop over here, and I'll start from 0 and I'll go all the way to 2. So you're seeing how having this for loop, it helps us go from 1, 1 to 1, 1, 2 to 1, 1, 2, 3. And then once I get to 1, 1, 2, 3, I'm gonna finally hit this case, and then my I is gonna increase to this one. And then it's gonna become 1 plus 2, 1 plus 2 plus 3, and then so on and so forth. And now we want to do is we want to see the average, right? And we want to compare the average and see if there's a value which like that which exists. So for this, first I'm gonna create a double average, because if you create an int, it can create some problems because not every time are you gonna have an integer. You see, if I add 1 plus 1 plus 2 and I divide it by 3, I got a double. So I want to keep a double, and I want to keep another int variable, however, int average 2, which I will use to check with which I'll use to check if there's any other values which of that which exist. So over here, right now we're going in this range, right? So we want to add to our average, which would be, or we could do this, average plus or minus temp dot k. So basically what this means is average is gonna go through each k. I'll just do it here. Basically what this means is average is gonna go in, right? And it's gonna take 1 plus 1, which would equal to 2.0 because it's a double, right? So our average is equal to 2.0. Now all we have to do is we have to divide it by the number of the total distance traveled, which in this case would be 1, right? I traveled 1, but you divide it by 2, right? Because I traveled total 2 spots. So it should be, and then your average would equal to 2.0 over 2, right? But 2, it's not always going to be 2. Like if I take 1 plus 1 plus 2, then that becomes 4, and I have to do 4 over 3, right? So instead of 2, it should be j minus I plus 1. And then maybe I'd want to, yeah, j minus I plus 1, like that. Because in this case, j would be 1, right? So 1 minus 0 is just 1. But you also want to add 1 to it because arrays start from the 0th position. So this will give us the value, the total average of the system. So that's what we're gonna do. We're gonna do something like that. And then once after this we go outside of it and do average over j minus I plus 1. So now what we have is we contain the average of these to all values. So in this case, the average would be 1.0, right? Now, all that we have to do, now that we have the average, we just have to check it with the values which we added. And if any of those values is equal to the average, well, our counter increases, correct? But before that, because I made it a double, I have to do some casting to an integer. And I cannot just, oh, hold up. And I cannot just check an integer to a double because at 0.0 makes a difference. So what we're gonna do is we're gonna say if average mod 1.0 is equal to 0, we'll take the average 2 and make it an integer of average. Now, why I'm not gonna convert every average is because let's say our average in this case, right? We take 1 plus 1 plus 2, which is equal to 4.0. And then we take average is equal to 4.0 over 3, right? When you divide that, what do you get? You get around, you'd get around, what do you call it? You get 1.33, right? 1.33. Well, if it's a double, right? If it's 1.33 and I convert this to an integer, would that make average 2 equal to 1, right? So then average 2 would equal to 1, which would equal to one of these values. I mean, equal to one of these values, right? But that's not what it is, right? Just because it's 1.33 and you convert it to an integer, it shouldn't become a 1. You should only convert it to an integer when it's a 1.0. Because if it's a 1.33, you don't want to increase your counter. But since casting works like that, it can create some problems. So you only want to round it off when it's when you mod it by 1.0 and it gives you 0. Because that way you know it's a perfect number, right? Else over here, what we can do is we could use a continue function, or we could do average 2 is equal to -1. So what this does is it makes average to a negative number, right? And then over here, it says it has to be greater than 1. So by making it a negative number, what that means is it's never going to be equal to any of these values ever. Because anytime you take an average, you're always going to get a positive value here because no negative values are allowed. So by making it negative, you're basically going to cancel it. And then now we're going to do some simple checking. Now what you want to do is we want to go through this process again. We want to go from I to j again. And this time we want to check our average, which in this case would be 1.0, with the values we just went through. And keep in mind, this very important is that this for loop cannot go outside of the other for loop, meaning this for loop, right? It has to come before it goes to the second iteration of this value. You see? Because if our j value iteration changes and then we check, it will create problems. So now all we have to do is we have to just check our temp. We have to check temp.get I2, and we have to see if it's equal to average 2, right? We have to see if it's equal to average 2, because if it's equal to average 2, we have to add it to our counter, correct? Because average, we have to add it to our counter, right? But another thing to keep in mind is, you see, in this case, if I add 1 plus 1, average it, I get 1.0. Now, if 1.0, and in this case, I2 is equal to I, right? So I2 is equal to 0. So is 1 equal to 1? Yes. So our counter will increase from 4 to 5, right? It will be 5, right? And then it will, I2 will now become 1. And then is temp.get1 also equal to 1, right? So does that mean our count will become 6? That's what's going to happen. And you see, that's a problem because we don't want to count this pair twice. You know, we already have it here, right? But by incrementing, we're essentially counting this pair twice. So what happens is this becomes 6, and then now we continue on, and we hit the second case in which is 1 plus 2 plus 3, and our count now becomes 7, which is 1 more than the actual value. So what we're gonna do is when we hit the count, right, we'll break out of it. And why we can do that is because we only want to take it once. Just because it repeats several times doesn't mean we're going to take it in several times. We'll just break out of it and take it once only. And now all our logic is done. All we have to do now is clear up our memory. Meaning after this iteration, so like you see after all this code here, we want to set average back to 0. Why would I want to do that? Because if I don't set average back to 0, what happens is average already contains the value 1.0, correct? Average already has 1.0. Now, if I add 1 plus 1 plus 2 plus 1.0, that now becomes 6 over 4, which equals 1.5. You see how it's different? That's different from, I mean, yeah, 1 plus 1 plus 1.0, it becomes 6 over 3, which is equal to 2, which is not the same as 1 plus 1. Oh, my bad. It's actually 5, but yeah, it's 5, which would be like 1.66 compared to 1 plus 1 plus 2, which is equal to 4 thirds, which is equal to 1.33. And in this case, it doesn't make a difference because it's a decimal, but that could cause a problem with other test cases where if you don't reset your average back to 0, you will keep adding on to your average, which could completely mess up your things. Now, we could always also set average 2 equal to 0, but that's not necessary because when you go back in the loop again, right? Like after this incrementation, you go back in. Average 2 is always reset back to a certain value based on average or -1. So it doesn't matter if you clear average 2. I could, in this case, say this average 2 is equal to 0 also. And maybe this average should be 0.0. 0 also works, but we'll just keep it 0.0. And then now that we have this, we just have to print out system.out.println. And we'll do count like that. And now if I run this, I should get my answer as 6 point. Huh. That's interesting. Did we increment count anywhere? That's interesting. Oh, so where do we do something wrong here? We have all our variables assigned, so it's not an array problem. All our variables are set. Count is just not incrementing. That's weird. I think it's a problem with some, but let's debug it. That's weird. That is weird. I will not lie to you. This. So why is it not incrementing? I is less than temp dot size, correct? Did we add? Did we? Oh, guys. Oh, the problem is here. We don't know what temp dot size is. It's 0. It has to be n here. That's kind of, yeah. You see, so now we get 0. So we're gonna download this file and Java submission and submit, and it should work for all the test cases. And yep. So it's working for all the test cases. So one thing I just also want to show is I just want to compare this to if I use an array. Just to show you guys that for bronze, it really doesn't make a difference. So here we'll just make what is it? We'll just make it all an array. So it'll become int temp is equal to new int and size. Oh no, can't comment everything. Just comment this. Array format is a little different. Comment that out. It should become temp.length. 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 Comment this line out and make it average plus or minus temp. Okay. And then over here, this would become temp I2. I might have made a little bit of a mistake, but let's see. Oh, you can't do that. I don't really know how to do this now. Haven't used the Rails in a really long time. Oh, that's stupid. Oh yeah, it's like this. Okay. Line 36. Oh, yeah, we can't have that. Yeah, so we get 6 again, right? And then we can download this file and then we'll upload this in Java. And well, then I'll get back my changes to array list because personally, I just like using array list instead of arrays because arrays have a set boundary. So you could sometimes get an array out of bounds. But I just want to show that arrays can also work. So yeah, here you can see that arrays also work, and you'll see slightly faster runtimes. Like this number one takes 346. Number two is surprisingly fast. So all of them are just generally a little bit faster. Like there's no 500s, but it really doesn't make a difference. Anyway, yeah, guys, thanks for watching.